And the reason I became interested in Toyota was not because it was lean, because the word didn't exist at that time, or not because Toyota was the benchmark, which I didn't know they were at the time, but rather because what I saw in Toyota was true socio-technical systems thinking.
If you've practiced lean for more than a few years, chances are very good that you've learned and benefited from today's guest, Dr. Jeffrey Liker. Dr. Liker has published a number of must-read lean-oriented books, including, but not limited to, The Toyota Way, The Toyota Way Field Book, and Toyota Talent. And as fate would have it, I had the great fortune, an honor to meet Dr. Liker at the most recent KataCon 5 Summit. Now on today's show, we're going to share the audio portion of his keynote presentation. Now, during the keynote, Dr. Liker opens by sharing his background and learning journey, which was quite interesting to hear. He then explores many aspects of his lean journey, including several lessons he's learned along the way. Now, show notes for this episode, which will include links to everything Dr. Liker discusses, can be found over at gembapodcast.com. Just look for episode 264. You can also check out Gemba Academy's Lean Learning System over at gembaacademy.com with a fully functional trial. Okay, enough from me. Let's get to the show.
One of the things that confused me about this conference was the word swag. So I looked it up. And it turns out it's highly desirable giveaways, which makes sense. But what does the SWAG stand for? And one is stuff we ain't got, and that kind of makes sense. But the one I really like is scientific wild-ass guess. And I think that I don't want to think of professional science as being a very orderly, systematic, deliberate process of discovering the truth, but it's a little bit more like scientifically wild-ass guesses. I started as a industrial engineer and became a social scientist, and I'll talk about that in a minute. And then I was at University of Michigan, and I learned about what the Japanese were doing and about Toyota. And at that point, Mike was a student of mine, and then the way I got into kata was a few years ago when Mike asked me to meet him at a coffee shop, and he gave me a signed copy of his book, Toyota Kata. I didn't know he was working on a book. I didn't know what kata meant, but he was obvious he was very enthusiastic about it. And then after that, we were talking on the phone, and he was saying, Jeff, I really think this kata stuff is going to take off, and I'd like you to be a part of it. And I said, okay. And he was a student, so he's not supposed to be telling the professor what to do. And he said, seriously, I think that this is the next phase of lean, and I really think you would enjoy being part of this movement that's going to happen. And it sounded a little bit odd to me that I don't think about movements, but anyway, the message really was the train is going to leave the station, and you can either get on it or off it, and it's your choice, but I'd really like you to get on it. So it turns out that I got on the train, and I've been, for the last about 5 years, spending more time studying kata and teaching kata than anything else. So I'd like to give you a brief tour of how I got to this point, starting with 48 years ago when I was an industrial engineering student. And I studied industrial engineering at Northeastern University, largely because I was interested in people and social sciences and human systems, and I'd gotten interested in that in high school, but my father thought I should do something practical, and engineering was practical. So on the way up to Northeastern University, my mother is reading the course catalog, and she's describing the different fields of engineering. And she got to industrial engineering, and it said that it was the integration of man, machine, and materials, dealing as much with the social sciences as with engineering sciences. And I said, that's it. That's what I want to study. So I went into industrial engineering with that idea that I was going to learn about how to integrate the social sciences with technical systems. But it wasn't that at all. It turned out that there was one course after 5 years at the very end that was called Personnel and Organizations, taught by a gray-haired guy like me now, gray-haired 60-year-old guy who had been in industry, and he was sort of telling war stories about his experiences. So the way I learned about what I was interested in was to take sociology courses for all the electives I had. And there weren't a lot. There were about 5. And there was a particular professor I got to know who inspired me, and that led me to get a PhD in sociology. The other thing, by the way, the other thing that happened as an undergraduate is they have at Northeastern University a cooperative education program. And you go to school and you go to work, and you go to school and you go to work. And the workplace I was at was General Foods Corporation, which doesn't exist anymore, but they made things like Bird's Eye vegetables and Post cereal and Kool-Aid. And they had also a dog food division that made Gravy Train and Gaines dog food. And in the Gravy Train and Gaines dog food division, they were a pioneer of what was called socio-technical systems theory. And the basis was to organize the factory around self-directed work teams. And this was a highly completely automated factory. And mainly the operators were watching monitors, and they were checking things, and they were responding to problems as they occurred. And they found that when you put those workers into groups, and the groups were multifunctional, and they included engineer, and they included people who knew the equipment, and were operating the equipment, they included maintenance people, and gave them a responsibility for a set of machines, they perform better. They're better at meeting their key performance indicators, uptime of equipment, quality indicators. It just worked better to have teams responsible rather than individuals. And I thought that was very interesting. And I started reading about socio-technical systems theory, which was based on open systems theory. One of the key ideas of open systems theory is that in a closed system, you can have rules, procedures, bureaucracy, top-down management, and when people follow the rules, things work pretty well because very little changes in the organization. But open systems theory says that that your factory or your organization is actually part of a much broader ecological system. And the world is changing all the time, and technology changes, and rules change, and culture changes, and people change, and there's so many dynamics that you can't predict and control from the top, and you have to give local control to people at the gemba, close to the machines, so that they can make decisions, real-time decisions and adjustments very quickly. So you have to adapt to change, sort of like the uncertainty that's in the kata model. So that I thought was very interesting. Then I went to University of Massachusetts, got a PhD in sociology, and kind of lost my way from my interest in people and socio-technical systems. And basically to make a living, I was good at computers, I was good at statistics, so I got hired to do that. So I was analyzing large data sets, and I was using a lot of statistics, and it was publishable, and I got funded. And then I continued to do that at Cornell for 2 years as a postdoc in a study of a big database of children of the Great Depression and then children of the Great Depression. So it was a historical study of the impact of the Great Depression. So very interesting, but I never talked to anybody. My PhD dissertation was about social psychological adjustments of released prisoners. So there was a large group, 2,000 from Texas and 2,000 from Georgia, from this state, and they were released, and we followed them for a year. And I published some really good articles in top journals, never talked to a released prisoner. Still to this day, I was just thinking about it today. These are felons and serious prisons. I've never talked to one in my life, but I published and I got helped me get tenure. So then in 1981, I was looking for a job as a professor of sociology, and it turned out that period was one of the worst recessions. The Great Recession was worse, but it was pretty close to that. And positions were opening up and they were closing down before they hired anybody. And I was feeling kind of desperate. It was around this time of year. And I saw an ad for somebody who would be an industrial engineering professor at University of Michigan, who they wanted to have an engineering background and a PhD in social science. So I called them up, and they said that they had almost closed out the search and decided not to hire somebody because they tried for 2 years and couldn't find anybody. So within a few weeks, I had a job at University of Michigan. Great university, low teaching load, very interesting, exciting place to be. And it was kind of like one of the universities I looked up to in sociology because they had a great tradition of sociologists. The only problem is that I hadn't studied industrial engineering or anything about organizations for the 6 years I was in graduate school and doing a postdoc. So I had to kind of go back to school. And I was pretty nervous. Not only that, I had to teach, which I hadn't done before. So basically, I had a PhD and I had my publications, but I had no experience and no reason why I should have been in that position. But the good thing was that being in an engineering school and being a sociologist, it turned out that I was attractive to a lot of research teams that wanted to have somebody from engineering as part of the research teams to study some sort of a social science topic. The two big topics at the time that in my first year were the implementation of new technology. Back in the 80s, there was a big movement for automation. Robots were coming into factories. They were developing computer-integrated technologies for computer-aided design and designing something and then having it suddenly appear built in the factory was kind of one of the images. They called it computer-integrated manufacturing. And there was a lot of concern about how that would affect people. Displacement of huge numbers of people from their jobs, as well as what were the skill requirements. And one of the things they concluded was that in a computer-run factory, there was more of a need for people to be creative problem solvers and less of a need for people to do simple manual tasks. So they expected that. So the socio-technical systems perspective became even more popular, that we really need thinking people who are reading the situation and solving problems in real time and are really smart and really educated to solve problems, and less people who just did stuff routinely, repetitively over and over again. So that was kind of interesting, and at the same time, there was what was called the Japanese invasion, which was Japanese bringing high-quality, cheap products to the US and selling them and beating the American companies they're competing against because their quality was better and their costs were lower. And there was a lot of concern about what the U.S. would do and how we should respond. And one of the places that was happening was in automotive. And that led to this big study called the U.S.-Japan Auto Study at Michigan to try to understand why the Japanese were so good at what they were doing and looking at every aspect, purchasing, product development, manufacturing, human resources, you can go on, and there were experts in all those fields trying to understand why the Japanese were doing so well. I was invited to that study. I was invited to be part of a number of studies that looked at the social impact of new technology in very automated plants. And for the first time, I actually talked to people. I actually went into factories and I interviewed people and they showed me what they were doing. And so I was starting to go to the Gemba, and I also happened to work with this one guy from sociology who was a qualitative social researcher. I had done all quantitative work, and his specialty was like an anthropologist to go into places and understand what was going on. And I learned a lot about how to take notes and how to observe and how to then turn that into publications. Then that led to then, and I also resumed learning about socio-technical systems. And there were a lot of interesting examples, like Procter & Gamble is one that in the 70s had adopted these self-directed work teams to great effect. And I had a student who had worked for Procter & Gamble, and we started doing consulting together on open systems theory and socio-technical systems and creating these work groups in factories. So that was all fun and interesting, but what sort of continued from that was my studies of Japan, but particularly Toyota. And the reason I became interested in Toyota was not because it was lean, because the word didn't exist at that time, or not because Toyota was the benchmark, which I didn't know they were at the time, but rather because what I saw in Toyota was true socio-technical systems thinking. It's like I had been looking all my life for this and reading about it and studying it and visiting places where they had these self-directed work teams. But in the plants, including Procter & Gamble, that had self-directed work teams, that's all they had. What they found is that when people talk to each other, they communicate effectively, and you have the skills and talent close to the work process, things worked better. So they did that, but there was nothing different about the technical system to support the people. There was really no integration of the social and technical system. It was really just the engineers were working on the technical system, and then the socio-technical systems people said, we really need to look at this as a socio-technical system, not just a technical system. So what they did is they then looked in isolation at the social system and forgot there was a technical system. That didn't happen in Toyota. And exactly the reasons for that are not completely clear, because there's so many different people over the long history in Toyota who are influential, including Taiichi Ohno, who created the first ever fully automated loom and spent his whole life inventing. And then his son Kiichiro Toyota, who started the car company and had the vision for just-in-time, and including Taiichi Ohno, who went to the shop floor, and he was the hack that made it work and made the Toyota production system into a reality, and created it and thought about it, and then all the students of Ohno, and there are lots of other people involved. And it was in Japan, and it was within a Buddhist context, and with all these influences, they ended up becoming a learning organization and having specific ways of thinking that I think of today as a socio-technical system. I'll talk more about that later. So then I put that together into my model of what I learned from Toyota. And the reason I wrote the Toyota Way was because mainly it was Jim Womack and Dan Jones and others who were writing about lean thinking and the machine that changed the world. But the book Lean Thinking really struck me. How many of you have read Lean Thinking? Okay, lots of you. It's a really good book, and it's really well done. And the idea was to give you stories, not just from Toyota, but from other companies, to show how they transformed using these principles, concepts, ways of thinking from Toyota. And the format of the story was, the company is a mass production, top-down, command and control organization. They bring in a sensei, Japanese sensei, not necessarily from Toyota, but a Japanese sensei, who basically tells them how screwed up they are. And in one case, they use the term concrete heads. You got concrete between your ears. I can't teach you anything. And then finally, they'd convince this sensei to teach them. And what the sensei is trying to teach them is they're trying to break the concrete and get the brain matter working again and the electrical signals flowing. And then the way they do that is through very dramatic approaches on the shop floor, like cutting down your racks to 3 feet high with a chainsaw and doing it right there and then and throwing the inventory on the floor and lots of dramatic things just to shake people up and get them thinking. And then they'd reorganize it into a flow and they put in Paul. And then at the end, there was a scorecard. And the scorecard showed before and after. And it was always a dramatic difference. So the message that came through, the idea of lean thinking I agreed with, and the message that came through was, we're not thinking, we've become kind of deaf, dumb, and blind, and we're just sort of moving along, following the rules without challenging them, and our machines are breaking down, and our people aren't being trained, and we're not doing anything about it. And if we can get people thinking more about customers and how value flows and how to develop people, then we'll get these great results. But the other message, which I didn't like, is that this is a discrete process. It's an intervention. So we have the before, the intervention, and then now you're lean. And for one thing, I didn't think that was a good message, because that's really, for those plants that went through that first year with the sensei, they had just gotten started. Basically, what he had done is got their brains a little active again. So now they're in a position to start to learn. But they were done. They had the results. And the other thing that concerned me was Anyway, so the other thing is that what you're doing is this physical change, and now that the processes are lean, now you're lean. So I saw this, I participated in changing this process, now I got it, now I can go off and continue to be lean. So my brain is changing really quickly. Oh, the other thing I was going to say is that my experiences at the time, and I worked with Mike Rother, I worked with Sean Shook, we were working at Ford, and they had 130 plants to convert to the Ford production system. I had never seen a single case that looked like those cases in the book. They were all so much more messy, and things just didn't work that way. And there was resistance, and they tried things that didn't work, and then the manager would leave, and the whole lean program would fall apart. It just never looked neat and clean like those chapters. So that led me to conclude that I really needed to go back to the Gemba at Toyota and understand more deeply what they were trying to teach and why they were so successful. And it wasn't just applying these tools in this very quick and dramatic way. So my model that I came up with, many of you are familiar with, starts with philosophy. And that's a way of thinking that I call long-term systems thinking. So you have to think about that we're a system, we're open to the environment, there's things are changing all the time, we can't predict the future, so that leads to the kata idea of experimenting, of iterative learning, of PDCA. If we can't know everything going forward, then we have to learn our way toward our objectives. So the Toyota people were naturally systems thinkers, and they believed deep in their bones that what makes Toyota successful, and the only thing that makes Toyota successful, are the people who are continuously improving. So if you see Toyota's model, this is my model, but Toyota's model, which is respect for people and continuous improvement, that's the Toyota way, the end of the story. It's people who are continuously improving, and the way you respect people is to challenge them, push them, develop them, and make them better people who are better at continuous improvement. Anyway, so in my model, why you exist is the philosophy, the way of thinking is the philosophy, that's the culture, it's a value system, and then there are processes to deliver value to the customer, and again, that's part of the philosophy, is why we exist is to add value to society, add value to customers. And the way we deliver that value is through people continuously improving the process using problem solving. And the kata is up at the top, what I call continuous learning. And this is real. This is not just me kind of making this up, but it's really, this is what Toyota does. It's the core of their philosophy every place in the world, and it's been true for the 35 years I've been studying them. Now, where would lean be? And it turns out that even Toyota has adopted the term lean, and they view lean as an input to continuous improvement, to Kaizen. In other words, when you're doing Kaizen, there's this way of thinking, there are these principles, and there are these tools that we call lean that inform the Kaizen. Now, the Kaizen itself is not designed to implement the tools. It's not designed to implement standard work or to implement Kanban. The Kaizen is designed to improve toward a goal, to solve a problem. But when you're doing that, you have a way of thinking, a philosophy, and principles to draw on. Just like if you're a carpenter, you get to know all your tools. You have to know how to drill, you have to know how to cut, you have to know how to use various kinds of power saws. But your goal in going into a house is not to find places to use my saw. It's to repair the house or improve the house or build an addition or build the house. And you pull out the tools as you need them. And there's some reasons why you're going to use a certain saw and other reasons why you're going to use a different saw. So you need to master the tools, but then once you master the tools, you're using them to solve the problem you're dealing with right now. So that's where they put lean thinking, is under continuous improvement, which I put in the foundation here. But another way you can look at it is that the tools of lean really directly affect the process. At the process level, we want work to flow better, we want less inventory, we want faster lead times, and we're influencing the process in order to better deliver value to customers. Now, the way that's happening is through people who are changing the process. In some cases, it's a technical process. It's a big stamping machine, we want it to work better. In other cases, it's not a visible process. It's how we in nursing and doctors work to get patients into surgery and out of surgery and recovered. And it's just a way of working. And it doesn't exist except in our heads and then as we enact it. So it's a human process. So in both cases, whether it's a purely technical process or a human process, from Toyota's point of view, the process doesn't exist in static form. It's just the best way we know today to do the work. And the way we improve is by improving the process, and that happens through people. So the problem I think we've had with lean is in a command and control, closed system thinking environment, we think that the way we fix things is through policies, procedures, and tools. And we think the tools, the processes sort of exist on their own, and they develop a reality that they shouldn't develop, rather than being in the heads of people who then agree this is how we're going to work for now. Anyway, so it's an integrated system. For me, a defining moment was when I visited the Toyota Supplier Support Center, which was set up in North America to teach the Toyota production system. And that was part of liberating the Toyota production system, making it available to the masses. And it was a Hoshin, a global Hoshin. And they decided if we're going to teach this, we should teach it in the only way we know that's effective, which is you actually do it. So they didn't want lectures, they didn't want training, they wanted to go to the Gemba and do a project and show you this is what we mean by the Toyota production system. And not show you individual tools, but show you how the whole system should work and can work in your organization. So you can actually experience it, not by visiting a Toyota plant, but in your organization. In Japan, it typically took about 4 months to do these model line projects. In the US, it took more like a year, just because of the different cultural differences. In Japan, they just do what you ask, and they work like crazy, and they make it work. In the US, we're asking why and hesitating, and it just ends up adding a lot of waste in the process, in a sense. But what was interesting was that I got to see the Toyota production system not in a big Toyota factory, but in small cells in supplier plants, and they were islands. So they would set up this lean cell, and it'd have standard work, and it would have visual management, and they would have an and-on system, and they'd be pulling material to the cell, and every other part of the factory was all push and mass production waste land. And it was so interesting to see that how well these cells function, how much better they function than anything else, and how the people were driven to improve and to make the numbers to meet the quota by the end of the day and to do the changeover within the 3 minutes. And the people were so motivated and so driven. In fact, one of the plants, they took me to 2 plants, and one of them was a failure in a sense where the cell worked, but the plant manager didn't get it, and he rarely came out to the floor, so they didn't spread it beyond that one cell. And the Americans in that cell, this is in Kentucky, they were wearing hats that had American flags. The hats were American flags. And I thought that was kind of cool that they were celebrating being Americans, but they were the only ones wearing them in the Toyota cell. And it turned out that that was a rebellion against the Japanese. They're mad that these Japanese people are trying to make them Japanese. And they were making them work so hard. So we get to a break, and everybody takes a break except the Toyota cell. And they continue to work. And I asked my tour guide, why are they still working? He said, well, you see the numbers, that's the target, that's the actual, they still have 5 units to complete. And I said, well, they're so mad at the Japanese and they don't like this system, why don't they just stop? They're entitled to a break. Well, they don't want to stop until they make the last 5. So it was interesting that even though they didn't want to do it and they were mad, the system was driving them to be engaged and keep working at a very high level. I thought that was fascinating. Here's an example of a one model line. This is in Herman Miller that makes office furniture, and they've pretty much taken the Herman Miller production system across all their plants. But it started in one filing cabinet plant with Mr. Oba, who was one of the Toyota sensei. He was a student of Ohno. He was one of the top people in Toyota who started the Toyota Supplier Support Center. And he walks into a filing cabinet plant that they had picked for the model line project. And he walks through the plant, and after about 20 minutes, he comes and says, I observed that you're making this number of filing cabinets on 3 shifts with 126 people and 2 assembly lines. My challenge to you is to do the same amount of work, the same number of filing cabinets with 2 shifts, 1 assembly line, and 16 people. And please don't buy any robots. Don't spend a lot of money. Now, does that seem like a reasonable challenge? And you talked about the green zone. That's the panic zone. But they didn't panic because they wanted him to come back. They're afraid so they dutifully said, sure, fine, great. How do we get started? His response was kind of looking a little confused, like, I thought I just told you. But he says, well, my suggestion is that you go and look at the assembly line. I noticed lots of people walking around instead of working. Maybe you can understand why they're walking around so much. Now, that for him, that's a lot of words. That's a major lecture. He didn't want to tell him that much, but he did. So then he said, I'll come back in 2 days and you can tell me what you learned. This is the way. So he does this, coming back, I think it was every week, and then he had his students, who were people from Toyota plants, who he was teaching the Toyota production system to, and they were learning to be change agents, and they were spending more time in the plant. But their instructions were, don't give them answers to any questions. They need to figure it out. They need to learn. They need to think. So through asking questions and then occasionally giving hints, they achieved this, whereby this is much later and they had stabilized the process, but by 2013, they were making more filing cabinets with 1 line and 2 shifts. They didn't get to 16 people, but they got to 30 people from 126 people. They got changeovers from 20 minutes to no changeover, and they got lead time down to 4 hours. So this looks like the lean thinking scorecard. But it didn't take a year. It took more than that. And they didn't do it by the Japanese sensei just ordering, do this, cut down the shelves. It was just questioning and letting them do work. But what they were really doing was Kaizen, was PDCA. So they work on 1 step at a time. And then they look back and they said, holy cow, we can't believe how far we came. And they have a Kanban system, they have standard work, and they have all the elements of the Toyota production system, but they can't figure out how it happened. It wasn't because they looked at the house and said, let's start with just in time, and then we'll move to standard work. And it just happened. And the way it happened was through PDCA, where each problem they solved made clear the next problem they had to work on. So it was really an organic process. Their journey, they could not recreate, and you would not want to recreate it any place. Okay, so what was he trying to teach? So now I'm putting this in terms of Mike Rother's model of kata, and I'm not sure that Mr. Ohno would even agree with this if he looked at it, but this is really what he was doing. He had a clear vision and for the company and what the company could be, and there was far away from that. But he gave them a specific challenge in the direction of that vision that he had of what the Toyota production system should be. And then he asked them, go and see, go and understand. We talked a lot this morning about how important it is to go and see. The first exercise to learn the Toyota production system from the famous Mr. Ohno. If you were Japanese and you were working for Toyota and or a supplier and you happened to be fortunate enough that Ohno would teach you personally, and you're shaking and you're nervous about the master, and the first thing he does is make a circle and make you stand in it and says, go and look, just look. And then a couple hours later, what did you see? And a couple hours later, what did you see? And this happened through the day, and then after 8 hours, he would say, you look tired, go home. That was the end of the lesson. So it's just an exercise, a kata, to get you to appreciate the power of observation, of deep observation, and taking the time to really understand. So we wanted them to learn that by going and seeing, figure out why people are walking so much. Then he didn't use the term target condition, but he would ask them, so what do you think you should work on next? And then he was basically asking them what they learned and what should work on next. They were doing PDCA, PDCA, PDCA. It wasn't structured like this, but in essence, this is what he was doing, and you saw the results. So it's starting with a customer-focused direction, motivating with an aspirational challenge, understanding the current condition, and then experimenting with a coach. And they were doing a lot of experimenting with a coach, even though, again, it wasn't structured in the same way as target condition, obstacle, PDCA, experiment. Again, that what Mike's trying to do there is to create a kata, a very deliberate, structured pattern that you can practice so that this becomes natural. To Mr. Ohno, this is all very natural. It's obvious. And the way he's going to teach you is in the direction of this approach, but not necessarily because he wrote it down or even thought about it in this structured way. But Mr. Ohno is not always there. So we're left with the rest of us who are sort of struggling along, and then it helps to have a more structured format to have kata. So the coach is developing and challenging people by questioning, not telling. This is very important going back to Ohno, because the whole goal was to make you think, to get the concrete out of your head, and to get your neural pathways flowing. So what Ohno said in a presentation, he rarely gave presentations, and I think he hated to do them, but I happened to get a PowerPoint deck from one of his presentations, and he says, TPS is built on the scientific way of thinking. Sound familiar? You need to develop a way of thinking. How do I respond to this problem? It's not a toolbox. Now, the key word there is this. So when we talk about science and professional science, again, it's messier than it appears, but what professional scientists are trying to do and what gets you published is trying to create some generalization. When this happens, this is likely to happen. And then you want to you can't prove the hypothesis, but you can try to disprove it and all that. But you're adding knowledge to that general principle, that general equation. And what he was saying is that's not what they're trying to do in the real world of Toyota and manufacturing. They're trying to solve this particular problem using science. And I think that's where the kata comes in, is the kata is not necessarily a universal philosophy of science, but rather a very practical way of applying scientific thinking to achieving very specific goals that you set for yourself in very specific conditions. And that's what he's saying that he wants to teach. And he also says you have to be really willing to start small and learn through trial and error. And that's very central to the Toyota way of thinking. This was just, I threw this up because I gave a presentation like this in Italy at a big conference, and they had hired this artist who was developing a graphic summary of the presentations of each of the speakers. And he knew nothing about me, nothing about lean. And I was kind of pleased that somehow with all the babble that came out of my mouth, he got this. And he actually got the messages. And it was also really well put together. But to the right, that box that says culture that encourages experimentation and learning. And I was teaching this before I knew anything about kata. Put the customer first, continuous improvement, leaders at the gemba, developing people and partners. To me, that was the Toda way. And it's really the reason why you want to use the kata and learn scientific thinking is because of that philosophy. Now again, that philosophy is in the foundation. It's foundational to the whole system. Without the right philosophy, the system falls apart. So if you have a command and control mechanistic philosophy, there's no reason to do something like the kata. People just come and go. And what you want are replaceable parts. The more you invest in people, the more money it costs you, but also the harder they are to replace. So there was a good story of a Japanese sensei coaching a CEO of a large company, and the CEO kind of figures out the level of investment required in people by this approach, and he blurts out to the sensei, but what if I spend all this time and money developing people and they leave? And the sensei says, what if you don't and they stay? But anyway, that idea of this level of investment in people, and we work on the process, and the results will follow, don't worry about it, it's totally contrary to the thinking of traditional top-down command and control organizations who are interested in quarterly returns and results only, regardless of the process. So the philosophy is very, very key. So what Toda Kata to me did was to take these principles that I've been teaching and preaching and trying to convince people about and turning them into very concrete action. You know, how do you do this? And Mike said, here's the model, but how do you do it? And that's where the kata came in. So I was at the stage of the model. And what the kata added were the principles, turning the principles into action. How do you do this? How do you get people, how do you clear up some of the concrete and get people to think more actively? I did teach a course at University of Michigan that involves Zingerman's mail order, and I won't go into a lot of detail except to say that I did it for 3 years, master's students in industrial engineering, brilliant students, and it turned out by chance, exactly when I decided to create the course was exactly when Zingerman's mail order decided to learn about kata. And I met with Betty asking if it's possible for me to send students to do projects in the warehouse, and she was thrilled because they were trying to figure it out. It turns out 10 students from Zingerman's came to my class each year and went through the whole course. So it was a really nice win-win. But one of the things I figured out was that these students who were really smart and their brain matter was much more active than ours, they're younger, top of their class, and they're really bad at the kata. They really struggled with it at every step of the way. And it was because of their mechanistic sort of closed system thinking that we should be able to solve the problem through theory, through models, through mathematics, through numbers. So understanding the current state means they go to the client, they collect whatever quantitative data they can, they disappear into their computer, and they come back with charts and graphs. So getting them to actually observe the process was something new to them. They hadn't done it in any of their classes. So that was an interesting experience to see how much, and they came really far by the end of the course using the kata method. That's the framework I used for the whole course. And at first I was a little nervous that it was too simple for these really smart kids, but it wasn't. So what I've concluded is that the kata is at the center of the Toda production system of scientific thinking in order to continuously improve. And then respect for people means you're being developed that your boss takes the time and effort and cares enough to want to teach you and develop you. But you still need to have a direction. And this is Mike's slide, where one way of getting the direction is through value stream mapping. But not the current state map with all your problems today, but rather the future state map with your vision of what you want the process to look like. And you can't do a good job of developing that vision unless you have, you can't develop a lean vision, put it that way, unless you understand lean concepts. And in that book, Mike and John, but mostly it was Mike, did a great job of a short tutorial on lean thinking. What is Heijunka? What is flow? Flow where you can, pull where you must. Very simple rules of thumb. Brilliant distillation into a very simple set of principles. But just like the kata, actually turning those principles in the book into a practice in a real situation is not easy. It's not automatic. You have to learn it. You have to learn about pull systems. You have to learn about standard work. You have to learn about one-piece flow. You have to learn about visual management. There are bodies of knowledge that you learn through doing, through practice with a coach. The body of knowledge can be summarized in the Charter Production System House, which I won't go into. But the real challenge I found, and I've had a consulting firm for the last 25 years, and sometimes it's been big and sometimes small. It's pretty small now, but we've worked with a lot of different companies. And when I'm in a consulting role and they're paying the bills, you have to kind of satisfy the customer. And they may not want to do everything you think they should do. So what I would like them to do is not this. I've been writing against spreading lean across the organization using the tools approach my whole career, it seems. And I want them to do this, to develop depth of capability. But in order to develop that depth of capability, they have to be willing to focus in an area first to learn, and then start to incubate the process across the organization by bringing people to that first test bed of learning, the model line, and then having them go back and go through a similar experience like they did in the model line in other, say, plants, if it's a manufacturing case, and not just try to copy what was learned from that initial example. Now, the idea of piloting in a technical sense, if I were to pilot some new kind of robot in a plant and I have similar plants, once I pilot the robot and I get it to work, I then put the robot into the other 30 plants. So it's pilot to get to work out the bugs and then deploy. But with lean thinking, it's not like that, because I'm not really deploying a technical solution. I'm deploying a way of thinking, a way of behaving. So the people that learned in that model line learned through this process, and what you want to repeat is the process of learning, not the outcomes, not the solutions. So by definition, it's a slow process. And it also is kind of like the loaves and fishes, that it multiplies magically. So if you start with 1, and then you go to 2, then you go to 4, then you go to 8, at some point you're going to have a lot and be broadly spread through the organization. But that takes years. So the challenge is that if I only were to dedicate myself to kata, to model lines, to going deep, like Mike says in his book, which I think is right, I wouldn't get many consulting jobs, or I'd get fired a lot. And I did get fired just recently from a good consulting gig because we insisted on using the kata approach. We started using it. It was working great. But then a new CEO came along, and he wanted results fast across the company. And he saw me as just a barrier, an obstacle to what he wanted to do. So I was fired very quickly. But the other thing that's happened is that, and I think part of it is to do with all these discussions I have had with Mike, and starting to, I think, becoming more humble and realizing how little I do know. So I had to ask myself, if a lot of companies, a lot of consulting firms are deploying lean tools and getting results, equipment, OEE, you might have heard of, but overall equipment effectiveness. The equipment's running better, it's running at a higher level, they're saving labor money, their quality is better, they're delivering on time, and they're doing it all through broad deployment of lean tools. Who am I to say that's a dumb thing to do? It actually can work. Deploying the tools broadly by skilled people can work. And we don't believe that it's going to have the sustainability or as big an impact as if they develop people who are deeply thinking and continuously improving within their area. But it does something. It does something good. So that's been sort of my struggle recently, is how do you balance the broad deployment, relatively rapid deployment of lean concepts and tools and methods with going deep? And I don't have an answer to that, but that's the question that I've been grappling with recently. So for those interested in lean transformation, I think kata is extremely powerful, and I think it is a philosophy, it's a methodology, it's a way of developing the capability for continuous improvement and for meeting challenging goals that seem impossible at the outset. But there's also a body of knowledge of lean, the total production system, that is very powerful as well. And really, I think the best successes in creating highly effective organizations will be marrying the two. Or another way of putting it is that the scientific thinking is a core part. It's right in the center of the lean system we're trying to create. It's a system. It's not just an isolated set of practices. And if you treat kata as just an isolated practice, you won't get the benefit that you can get from creating a whole system. Thank you.
Thanks for listening to the Gemba Academy podcast. Now, we invite you to take a no-strings-attached, fully functional test drive of GembaAcademy.com. Gain immediate access to more than 1,000 Lean and Six Sigma learning resources, all free of charge, at GembaAcademy.com.